this video we'll have a look at a logical address and physical address and also the memory hierarchy. So we'll start with the hierarchy of memory, where it is, what it is, then we'll go in depth with addressing and other stuff. For example, in this image we are seeing three things. One is a disk, another one is a RAM, which is the greenish thing, and the last one is the CPU. Disk is nothing but your hard disk. When you open up your hard disk, internally it looks like the circular disk, which is controlled through motors. That's why you get a lot of noise when the hard disk is running. All the sounds are coming. Okay. And the next part is the RAM. Obviously you might have seen somewhere or there the greenish thing. It's like a scale kind of a look it will have it. And the third part is the CPU, which is the guy who is processing all the things which you are doing. He is the mastermind of your things. Okay. In this, the hard disk is like the latest is like SSD type, which is same as your memory chips, like which you put in your tab or your mobile. Okay, flash memories all. In flash itself, you have different types of flash memories. We'll not go into that. So the idea, so to recap this stuff, we have a hard disk and the memory, which is a RAM, main memory that is called, and the third is the cache. Okay, which is inside CPU. So in this image I have put in three parts. So the first part is the cache memory, which I haven't shown anywhere in the previous picture. Actually the cache memory sits as part of the CPU, and that is the fastest thing, okay, which is available for the CPU. CPU is like a Ferrari car, okay, whereas most of your memories are like your local bus, city bus or your bullock carts. So that is a correlation which you can have it. So trying to match these two guys is the trouble which we face it. So the cache, L1 cache sits, L1 or L2 cache sits as part of your processor, and even they have an external, for example, if it is a GPU thing, you will have a external cache as well, which is very near to the processor. And the primary memory is nothing but the greenish thing, which is your RAM. Whenever anybody who's talking about memory, when it comes to program, everything is main memory, nothing else they are meaning it. Okay, so in C or C++ and Python, the memory is memory crash, all those things is mainly because of this guy. Okay, if things are not available here, you will not be able to run it. And the difference between the primary memory and the secondary memory is like the secondary memory is run through a motor. Okay, and you have a spindle. Spindle is kind of needle of thing which reads the circular rotating disk. Okay, so you can see that in the part of the hard disk thing. So if you open the hard disk, it will look like that. So anyhow, whatever you do it, the motor is always have a speed constraint, right? Like RPM is there. Whereas in CPU or in the RAM, it is more of electrons or the magnetic things which transfers. So you can't match these two guys. Okay, that is the why there is a speed mismatch between all these things. So let's start with the simple memory management. The simple memory management is like we'll go to old days where you don't have computers or operating systems. You have a 8085, not even 8085 or 8086 chips, which runs a single piece of code. Okay, or even in current days, like your iOS mobile is like it's not multi-threaded, I guess it's single-threaded. Okay, so a single-threaded environment is like, but I have a piece of memory and I have a driver. Everything I have to do it on my own. So anybody who is working in embedded or who has worked from an electronics background will know it. They have to write all the device drivers. They have to write all the memory management things. So they'll not have any operating system at all. Typically, if you look through it, operating system is nothing but a program on its own. That's all it does. It helps you to do things much faster. Actually, whenever you bring someone on board to do your things, you have to spend money or time or space for them, right? So that's the thing which goes for the operating system. So instead of you doing things, memory management and the device driver, the OS like Linux or Windows or whatever it is, it takes care of for yourself. So in good old days, like every what is that chip or the processor, microcontroller, typically they call that as microcontroller. It's even not a microprocessor. Okay, so the microcontroller will have its own thing. Everything is managed by your own program, and it can run only one process at a time. Okay, it's called a monoprogram environment. Okay, then slowly came into the OS. So first when they started, they thought, okay, we'll put all the OS inside the ROM. Okay, so instead of putting that part of, I mean, there is something called RAM and ROM. So RAM is random access memory, the same flash memory only. ROM is like read only memory. Once you write it, like, you will not be able to modify it. So what they assumed is, like, if you put the OS inside the RAM, people will try to tamper it. So what will, I mean, not intentionally, at least by accidentally it would also happen. Okay, there are mischievous fellows who does that intentionally as well. So they moved the OS to the RAM, and they were not able to do that properly as well. Then what they do is they moved that RAM to the OS back to the RAM, and they kept only the device driver in the ROM. Okay, finally what happened was, like, even the device drivers, they were not able to fit into the ROM, because it kept changing. Okay, so what they did is they kept basic minimal things like a BIOS and other things, basic input and output system, all those things in the ROM, and rest of the things they kept it in the RAM itself. This is how it was there. Okay, so, and whenever you want to run another programming, you have to swap the thing. Okay, that's where the swapping comes into the word swapping comes into the place. So you have one space, you kick that guy out and then put the second guy in. Okay, so the next next topic which we'll be moving on is the address space. So before going into the address, like, we'll get an analogy of what address is. Like, for example, my name is Arun. Okay, that is my identity for the world, at least. Okay, but when I go to the college, they prefer, I mean, apart from my friends, the college or the other documentation purpose, they refer me with the roll number. It clearly helps them to identify uniquely a person. That is one point, and it avoids the confusions, and they are able to manage that properly. For example, there were a couple of Aruns in my class itself, so we used to have a lot of confusions when somebody calls out the name Arun. Okay, so those kind of confusions will not happen. The same thing goes for memory as well. For example, previously we had only single memory, then came primary memory, secondary memory, tertiary memory, all these kind of memory. The OS got into a struggle, so they want to treat every memory as in the even way. So they gave a logical address to all the guys. Okay, the physical address you can call them as a hard disk or a RAM or a ROM, whatever it is, but for the OS it's all memory. Okay, it assigns a logical address. It sees like a full room full of memory, and one part of the memory starts from 0 and goes till 10,000. Like that, it gives a number to it. What it does is, like, it was able to manage the memory very efficiently. Whenever it goes in, like, so roll number goes off, so they said, like, this segment is over, kind of it. They can do it, and that address is a virtual address. It's not a real address. My roll number is not my real name, it's a virtual name. Whereas the physical address is the real name which I have, like my Arun Prakash is my physical address. Okay, and it is seen by the memory unit. Okay, the address is, so whenever somebody calls my virtual address, what it does is, like, the CPU calls the logical address. It goes to the memory management unit. Most probably here my roll number is the MMU. I am the MMU itself. I take my logical number and convert that into my physical address and say that, hey, this is my number, so I am here. Okay, sometimes there could be couple of Aruns here, like the MMU of his brain will translate, hey, I am Arun Paul, like that it will say that. Okay, so any program from the user will never uses a physical address. It always deals with the logical address. Okay, this is some of the very important basic thing which you have to remember. Okay, and most probably there is always a limitation for a program to handle a memory, because the reason is, if you give an infinite memory, you will not, other people will not have a memory. For example, if you want to run a VLC player as well as a Word, if I give all the whole memory to the VLC, it's gone. Okay, so the logical memory is split up into logical address spaces. They call that as address space, and give one address space to a certain program and other address to the second program. Like that it goes on. Okay, so things we need to recall is the speed of the memories, like L1, L2, RAM, ROM, secondary, tertiary, and the address spaces, different address spaces, and the different type of address, logical address and the physical address, why it is there. And this is how when a program runs, it translates the logical addresses. Let's assume 346. There is a relocation register or MMU. Forget about the jargons. It translates into the actual physical address and gives you the memory. Okay. Thank you, friends. Bye bye.